In this series of videos, we're going to take a look at how to graph some rather bizarre rational functions. Each video will have a different example, however this beginning part's going to remain the same. So you may want to skip around and watch the series if you want to see some different examples. The reason this intro is going to remain the same is because some of these rules, all of these rules, apply to every rational function we're going to do. Namely, whatever makes the top of our function equal to 0 is going to be our x-intercepts. Whatever makes the bottom of our fraction equal to 0 is going to tell us where our vertical asymptotes are. And then our horizontal asymptotes, if there is one, is going to depend on what the degree or the highest exponent of the top and bottom of our fractions are. So in other words, the first video will take a look at this example where there's a bigger degree in the bottom. Our second video will take a look at what to do when the degree is equal in the top and bottom. And our final video will take a look at what to do when the top degree is the bigger degree. So let's go ahead and look at our examples. The first thing that I like to find when I graph rational functions is the x-intercepts. To find the x-intercepts of a rational function, I'm going to set the numerator equal to 0. Whatever makes the top equal to 0 will be my x-intercepts. And so this quadratic, I will either need to use the quadratic formula to solve, which I would not prefer you do, or instead factor, which is what I would prefer you to do. So let's factor this trinomial. I need two numbers that multiply to -4. And also add up to 3. And the two numbers that do that are going to be a +4 and a -1. So that's what this factors into. From there, I can get each of my solutions. My solutions are x equals -4. Hopefully you recall how to do that. And +1. And so I have two x-intercepts this time at -4 and at +1. Now I don't really like to write the points that way because the points that way because it looks like a single coordinate and it's not. So really what I'd prefer you do is let's write that as -4, 0. That's one of my x-intercepts, and then +1, 0. So let me get those points graphed. I don't know much about what this is going to look like, but I know it'll cross the x-axis at -4, and it'll also cross at +1. So next up, I'm going to find the vertical asymptotes. To do this, I'm going to set the bottom of my fraction equal to 0. Anything that would make the bottom equal to 0, there'll have to be a break in the graph at that point because I cannot divide by 0. So this time there's just one vertical asymptote, and that's going to occur at 2. I cannot plug 2 in for x. That would get me a denominator of 0. So let's draw that in. So there's going to be my vertical asymptote, splitting my graph and dividing it up. And the final piece of this is going to be to find my horizontal asymptote, if there is one. To do this, I need to check the degrees. The degree is the highest exponent, so the degree of the numerator is going to be 2, that's my highest exponent, and the degree of the denominator is going to be 1. Well, in this case, we have more degree in the top, or what I call it a top-heavy one. According to the chart we took a look at a minute ago, when the degree of the top is bigger than the bottom, it means there is no horizontal asymptote. So there's not going to be one in this case. Now don't put 0 there because that's something a little bit different. In this case, there isn't a horizontal asymptote. I had mentioned in that, or you may have seen in the notes, there was a but with this. And I think I'm going to save the but for another time because it's not going to matter too much to us at this point in Algebra 2. There's a but. There's something we can tell, but let's not worry about it. Let's just say there is no horizontal asymptote. To finish this one then, to see what this looks like, I'll need to graph it on my graphing calculator. So let's switch over and take a look and see what this graph looks like and then make a sketch of it. The final part of one of these problems is actually to graph it and see what the graph looks like. And to do that, we're going to use our graphing calculator. So notice I've entered in my function. I've included parentheses around the numerator and denominator. I need to do that anytime there's more than 2 terms in there. So let's include those. And I'll hit graph and let's see what we see. I can kind of see this part of the graph, which you see drawn down here, but I'm missing this. And so sometimes it's important to zoom out to see what we need to see. And so before I do that, I can kind of see that vertical asymptote right there at 2, like we predicted. I can see that those 2 points, 1 and -4, are in fact x-intercepts, and I can confirm that in my table. In order to zoom out, a really easy way to do that is just select zoom, and then option 3 will zoom you out. So press 3 and then press enter. So sometimes if you think there might be more to these very bizarre looking rational functions, you may want to do that. Zoom out so we can see that other piece of this up here. And there is my little note that I made that I had zoomed out to see that portion of my sketch.